Cognition-based end-to-end network slicing and slice management framework. The SliceNet webinar series started already last month, and what we want to inform you is that all these sessions are available online via the project website. So the webinar today is on cognitive slice level quality of experience management, and it will be presented by Kenneth Nagin from IBM Haifa in Israel and participant in SliceNet, part of SliceNet consortium. Kenneth is with IBM Haifa Research Lab since 1985, participating in both international and national research projects. Kenneth's research focused on AI users for cloud providers, and Kenneth has a large number of published papers and holds over 20 patents. Before I give the word to Kenneth, I would like to inform everyone that the session is being recorded and that it will be published on the website. And participants are welcome to post the questions via the chat, and then points where Kenneth finds that we should discuss the questions, I will give Kenneth the questions for you. So I will ask everyone to mute, even if at the moment is not a problem, and give the word to you, Kenneth.
Okay, thank you, Maria. Thank you. I think this is really appropriate since we just observed it's cognitive slice level quality of experience management, and we've seen how I don't think WebEx knows that we are having these problems. So if we had a system where we could get quality of experience or derive it, it would be most helpful to this particular cloud application. Okay, so to get started, I don't really know what everybody's background is, so I'll walk over some terminology. First, when we use the word cognition, I'm talking about artificial intelligence, machine learning, big data, and we want to apply this to the operations and the management for network slices. Next terms are quality of service and quality of experience. Quality of service is how a provider, in this case a network provider, judges how the quality of their service. And they usually do that from all the monitoring that they have on their infrastructure. Quality of experience comes from the users of the whatever service is provided. In this case, the users of the slice, a network slice. The next terminology used is vertical, and that's the network slice user. And then we talk about the network service provider and the digital service provider. The network service provider is the one that's actually providing the infrastructure and all the services to allow network slices to be used by a user. And you can think of the digital service provider as a broker of network service providers, because a user might want to have a network slice that crosses multiple network service providers. Finally, we have the terminology plug-and-play, plug-in. In this terminology, this is the way in SliceNet we've allowed that the vertical can provide feedback to the system using plugins that can be added to the system. Our basic goal here is cognitive-driven problem determination. We want to predict problems before the quality of experience degrades for the user. And cognitive-driven remedial actuation. Here we want to automate the network optimization. Basically, this is that when we've used cognition to derive what there's a problem, we want the remedial actuation to fix the problem. And finally, we want to keep the vertical in the loop, get feedback from the vertical, the user of the slice, and and then give them some feedback to them. Let them give feedback to the system, and then give feedback back to the vertical about how things are going. Okay, our basic agenda is our purpose and objectives. Why is cognition required for Slice quality of experience management? Requirements and challenges. Why is it hard? The technical approaches for design and prototype. What are the basic building blocks? What's the architecture? Achievements. What did we actually accomplish? And industrial vertical application contribution. How does it apply to the real world? These are our use cases. And finally, in the summary of innovations, there's a wrap-up in time for more questions. But that doesn't mean you shouldn't ask questions if you want to, but there will be time afterwards. Why are we using cognition for Slice quality of experience management? Well, there's many workloads, and there's dynamic traffic patterns. So we must constantly adapt and anticipate problems so that we can fix them before the user feels them. We have multiple data sources, multiple owners, multiple semantics. There's multiple layers within the system, and there's multiple domains. That means multiple network service providers. And we must combine the sources, all these sources, interpret them, and predict outcomes. And we want end-to-end quality of experience per slice. And I want to emphasize it's per slice that we're talking about. So, and we must derive quality of experience from the quality of service. What does this mean? It results into explosion of possible per slice state and possible configuration. And we have to scale up with this explosion. Traditional problem determination, for example, thresholding, is not adequate for this purpose. It requires cognition. So what are the challenges? Well, the first challenge we have to do is combine cognition with traditional network operations management. Now, this is another way of saying we don't want to throw away the baby with the bathwater. We use event actions and policies to allow us to scale up to this problem. We have many machine learning methods, so we have to allow easy integration of the new analytics. This is a big data management problem because there's so many sources and there's many components that are using the data. We need to harmonize under a single architecture. We have to allow mix and match of different tools, orchestration of cognition across layers and domains. There has to be one paradigm for both the network service provider and the digital service provider. Finally, we have the problem of quality of service versus quality of experience. Network level quality of service KPIs do not reflect the end-to-end quality of experience. We must estimate and predict the actual quality of experience. Okay, so let's take a bird's eye view of what we need to accomplish here. First, when you look at this, the red is the black is what is traditional management of a network system, whereas the red is the cognition part that we're adding to the system. So what happens? You have a 5G network, 4G network, it doesn't matter. You have monitors throughout the system monitoring the quality of the system. It's looking at the network flows, topology, resources used by the network, and they're feeding them into a data lake. We also have the vertical providing feedback into that data lake. And we have slice level monitoring. We're looking at taking all of this data, but then dividing it into the slices related to slices. The slice monitoring is fed into the analyzer. That's where we have the machine learning models. If the machine learning models see that there's a problem, it hands it over to the optimizer. The optimizer looks at it with consultation with the policy framework and decides what remedial actuation is required. Actuation comes up and then communicates this to the orchestration framework. The orchestration then orchestrates controls onto the network, hopefully fixing the problem. And the monitoring continues to see if the problem actually was solved. Okay, to find this, contextualize this, we into the SliceNet architecture. Okay, again, black is basically what is traditional management of a network, and red is what the cognition part. So if we look down here, we have these monitors, the resource monitor, traffic monitor, topology monitors, and you can add other monitors. They feed into a data lake. Aggregator reads the data lake and aggregates these measurements. These are usually time series measurements that it feeds into the analyzer. Again, the analyzer is the model where the models are, the machine learning models are. If the analyzer sees a problem, it passes it on to the QoE optimizer, which in consultation with the policy framework decides on what is the remedial actuation, goes over to the SliceNet orchestration subplane. He does the orchestration in communication with the control plane to fix the problem. In addition, I want to bring your attention to that we have a plug-and-play plugin that allows the vertical to feed monitoring its data into the system, into the data lake, and into the analyzer. So we can combine this data that's coming from the provider with data that's coming from the feedback that's coming from the vertical, and so the analytics can be richer. Any questions? Okay, I'll continue. Okay, then here we want to look at this from a process point of view. We have what we call the MAPK cognitive management route. Again, we look on the lower side here, where is the basic way of managing a network. And they're feeding, the monitors is feeding information into the data lake. We have a quality of experience monitoring reading from the data lake, passing on to be aggregated to the analyzer. The analyzers are where the models are. The models decide the problem, if there's a problem. If indeed that there's a problem, the policy framework then with and the quality of experience optimizer and the policy framework decide what the remedial actuation should be, communicated with the orchestrator. So we call this the cognition loop. Okay, so what happens? How does this happen? In the first stage of things, we have to train a model. This is done with historic data or simulation data. So we take that data, create a model with that. Then at runtime, we use that to do problem determination. Problem determination feeds into a policy framework in the QoE optimizer to do the actuation, which hopefully fixes the problem and loop back and continuing the monitoring. Here we have a view of how this works with the vertical, keeping the vertical in the loop. Here we use plug-and-play plugin, and to do feedback into the system. We feed back to the user with a dashboard, and the feedback is read into the analyzer, which then decides on what the actuation will be and notifies the vertical accordingly. Okay, so let's make this real. We have 3 use cases, and we'll look at the 3 use cases and how we apply cognition to these use cases. Our first use case is a smart grid. The smart grid is a power grid, and slices are used for the monitoring and control of this grid. The model then has to be watching the network slices to predict RAN degradation or RAN failures from the alarm data. It uses a neural network. There's a lot of in this particular model, there was a great deal of historic data available, and neural networks are very effective tools to doing modeling when you have a lot of data. Okay, so if there's a problem, we see that the model sees that there's a problem and there's a degradation. It then has 2 remedial actuations at its disposal to decide on which to do. It can modify SliceNet parameters, that is, change the bandwidth, or do a failover to a new RAN in the same network service provider. What would be the quality experience? The power grid is continues to be under constant observation and control. The smart city use case is a use case of a lighting system within a city. In this case, we use slices to monitor and control the lights. Here, the objective is to turn the lights on when they're needed, when there's people around, but turn them off when they're not needed, so that the city can save power and obviously reduce its budget that way, not have to spend so much money on lighting. The machine learning model that we're using is a random forest model. Its objective is to detect performance degradation due to noisy neighbors. Okay, what does noisy neighbor mean? Well, if you think about this, the network service provider provides multiple slices to multiple verticals. In one case, the smart city is one of the slices, but it's sharing the same infrastructure with other slices, other users. These slices could be the noisy neighbors. So if you have another slice that's using a lot of resources in the system, it will result in traffic congestion, which will affect the smart city slice and its ability to do what it needs to do, its monitoring and control. So if the system notices, the analyzer notices that there's a performance degradation due to noisy neighbor, it has multiple remedial actions that it can do. One is it can do bandwidth, the same thing that we had, adjust the bandwidth, the same thing that we did with the smart grid. It also has VNF scaling. In this case, this is a OpenStack system, and the virtual network functions are being represented by VMs. So you can scale these VMs. When scaling a VM is adding CPUs to the VM, or adding storage to the VM, storage and memory to the VM. You could also do migration to another host. So if you can migrate the VM to another host, and that host wouldn't be sharing the same resources then, so there wouldn't be contention between the smart city and the noisy neighbor. Of course, it could add it to the You could migrate the noisy neighbors, or it could migrate the smart city, depending on what the policies are. The quality of experience that we're expecting is all signals from the light sensors received as usual and no loss of the control of the light. Finally, our third use case is the e-health use case. In the case of the e-health use case, we have an ambulance traveling to the city, and it has a patient. So it wants Slice, it uses network slicing so that the emergency medical team, the EMT, can videotape the patient as on their way to the hospital, so that they can videotape the hospital workers, the doctors and nurses can monitor the patient and give advice to the EMTs on what they need to do to help the patient, like a stroke or a heart attack. All of these things need immediate response, and so if they can give more information to the EMTs of what they can do with a patient, they could save somebody's life. Okay, the data coming from the ambulance comes from a mobile that's videotaping the patient. This is allowed by these plugins that we allow the vertical to feed in the system. Okay, so what is the model that we're looking here is an anomaly detection model. It's implemented with random forest, similar to the smart city. It observes the network behavior for the last 5 minutes in order to forecast the signal strength degradation within the future 5 minutes. If it discovers that there is a degradation that's coming up, it avoids this by using traffic redirection within the same network service provider or handover to another network service provider. So what would be the quality of experience? No degradation in the video stream noticed by the health. Any questions? Okay. Prototyping. We have our prototypes here.
Sorry, Kenneth. Sorry, I was double muted. Okay. So, in fact, it is covered. By now, we have only one question from Ravin asking what data will be coming from the vertical. And if you would have examples, it would be great. So partially it's covered, but anyway, you can address the question. What data will be coming from the vertical?
In the case, this is the case that we have. In the e-health use case, okay, the mobile is, or it's called a user equipment, is feeding its perception of how it's the video, because if you think about it, there's a network here, and there's response this user equipment, or the mobile that's videotaping also has information of what its quality is. And then you also have information coming back from the hospital on this. And in addition, you have information in this loop, there's some artificial intelligence called, I forgot the name of the application, that's also giving advice into the system. So what you hear is that you have to feed in the information that's coming from the device that's actually doing the videotaping. But the system is, the main thing is that we want to, the plugins, this plug-and-play plugin that we allow for allows all sorts of information. You could imagine that the vertical plugin and feeding in other information from users of what they're experiencing. For instance, we just experienced this with WebEx. If we had a mechanism that would have allowed us to complain back to WebEx, our system allows that plugin to be there. We have a software mechanism that allows you to create plugins and that you can feed metrics back into the system. I hope that answered the question. This is, yep. Yes?
You can continue, yes.
Okay. Okay, prototyping. Okay, so we have some, this is, we try to be as much open source as possible, and we have things on GitHub as well as some Docker models in the case of the policy manager. And at the end of the slide, we have a place on the SliceNet website that points to the different prototypes. Okay, what were our innovations? First is we're cognitively driven state analysis and problem determination. We have multiple machine learning models to support. We have a system that allows us to do that. You saw 3 models. There's more models can be provided. And we have one paradigm for both the network service provider and the digital service provider. It's cognitively driven remedial actuation. We saw that these models trigger actions to happen. It feeds through the policy framework. And also you can notice that we have actuator decoupling from the triggers. They're reusable. The example that we saw in the use cases was bandwidth adjustment. And you see that we have cognitively driven problem determination and actuation, but we've combined that with the traditional network management in terms of orchestration, control, and monitoring. That's slice aware, and we've kept the vertical in the loop. So we have the plugins that I just talked about, and this allows us to create vertically informed quality of experience sensors. Finally, we have the data lake, and this is where we allow data sharing between the monitors and the cognitive subplanes, and between the network service provider and the data service providers. This also allows, from a software engineering point of view, a decoupling of the components so that they can evolve separately into the system. Finally, we have further information. You can find it here. Any more questions?
So, okay, thank you, Kenneth, for the presentation. And there is another question from Mark. Would it be right to say that end-user quality of experience is cognitively mapped to network quality of experience parameters?
Yeah, we try to derive it. It's not a 100% mapping. But if you think about it, you judge, you're using models in the case of the e-health case. You're using information coming from the user, and then you have to decide how you're going to fix the problem. So that is a direct mapping to it. We worked on an experiment, but we don't have a use case. It's not one of the use cases where we took simulated data and mapped it to network flows, and we also added the quality of experience that we judged from that. And then we run that at runtime without getting input from the user. I don't think I explained that well. What you do is we correlated between the matrix that we did on the network side with what we got from the user side, and then at runtime we only use the network side matrix. More questions?
Hellos. From OTE, I wanted to ask a question regarding if we want to try to replicate something from the repositories. Are there any special hardware requirements that would be required in order to replicate a VNF or something?
To replicate the what? Thank you.
The VNF, some of the VNFs that you mentioned from the repositories.
Okay. I don't have a good answer for you. Maybe somebody else on the call does, but we have this audio problem. I think that the information can be used. Certainly, let me go. Okay. When I look at this list on the repository, I think there are, in many ways, all of them are reusable in other situations. The policy manager is generic, and the optimizer and the plugin and the client, those are very generic things that can be used. In the case of the RAN NS prediction model, that's a hard one. But if the vertical was a power grid, then it probably could be reused. I hope that answers the question.
Yes, and I can think I was mostly asking because of the NSP and DSP examples that you showed earlier. But thanks.
Okay. I think there's other people here that are on the line that might have better answers, especially on the NSP side.
So, okay. It seems that no one wants to add something, but if someone from the project wants to add, please give indication in the chat. Meanwhile, we have another question from Praveen. Do we also evaluate quality of service of artificial intelligence service?
Our artificial intelligence service, or one that would be providing that you would provide within a slice? That is, the vertical has an artificial intelligence service. That's the question. Are you asking about our artificial intelligence service or the
provided by the vertical? So,
okay, good example.
You evaluate quality, yeah.
This is a good example. No, we didn't get that far. Okay, we didn't get that far, but it's a really good idea. The eHealth use case has an artificial intelligence receiver of the video called the Telstroke E application. I should have written it down somewhere. I did have, if there's somebody on the line that can talk about it better than I can, but we did talk about the idea of using it to feedback what it's experiencing, what it's experiencing in a way that we could develop a draw quality of experience from that. The way you would do it is that you'd run a lot of good slices on it, and train it on good slices, and get the information back from the artificial intelligence. Oh, I didn't explain it. This artificial intelligence, what it does is it reads the video, it interprets what it thinks the patient is experiencing, and then feeds back data to the EMTs on what it thinks they should do with the patient. It's like acting like a virtual doctor, giving a diagnosis. So I discussed with them the possibility of training a model on good data, that is That would be good. And then without any noise or any problems on the network. And then you could distinguish between what its signal is coming back with what it would be when there's traffic injection. So it is theoretically possible, but we never really, we didn't get that far to actually do the work.
Thank you, Kenneth.
Okay.
Is there any other question?
You're welcome.
There is another question from Jordi Baranda from CTTC.
Okay.
Sorry. How have you trained your machine learning models?
Each machine learning model was trained differently. The smart grid is was done from historic data that they got from, and if somebody from Altus Lab is here, they can describe it better. Actually, we have slides on it. I can go there.
Are the data sets available?
Are the data sets available? I don't know. I don't know.
It's José Cabaza from Altus Labs. Well,
Say you are very far away. Can you try to?
I'll try to speak a bit louder.
Yes.
The data sets are from the company of Portugal. It's called MIO, but they are for internal purposes on the SliceNet project. They are not available for external purposes. But yes, it's historical data from the network equipments of the network operator. Yeah.
Okay, thank you. Thank you, José, and thank you, Kenneth.
Thank you.
Are there some other questions or points to be discussed? So, if there are no other questions, thank you very much for everyone for participating, and mainly with the constraints that we had with the WebEx connectivity. And thank you, Kenneth, for presenting the work. I'm not sure if so. The indication on my computer is that the session is still being recorded, but we are not sure if the recording will be usable. Anyway, we hope so, and if so, the video of the session will be available on the website soon. I hope you participate in the next sessions as well. If you didn't register, you still can register to those on our project website. Otherwise, you will receive the login data before the next sessions. Thank you very much for everyone's participation.